In today's video, we'll be discussing about Physics Paper 1 MCQ Paper 2015 October-November, Variant is 11 and the subject code is 9702. Question number 1. What is the unit of weight in terms of SI base units? So we know that weight is equal to mass into gravitational field strength, and the SI unit of mass is kilogram, and gravitational field strength is same as acceleration due to gravity. So the SI unit of acceleration is meter per second square, so it is kg meter per second square. Question number 2. At temperatures close to 0 Kelvin, the specific heat capacity C of a particular solid is given by this equation, where T is the thermodynamic temperature and B is constant characteristics of the solid. The SI unit of specific heat capacity is joule per kilogram per Kelvin. What is the unit of constant B expressed in SI base units? So we need to find the unit of constant B. So by using this equation, first of all we need to make B becomes the subjective formula, that is B is equal to C by T cube, and C, we know that C is the specific heat capacity and its SI unit is joule per kilogram per Kelvin, and T is the temperature, so its unit is Kelvin to the power cube. Then as we can see that here it is joule is present and we need to convert joule to SI base unit. So we know that the SI unit of work is joule, and we know that work is equal to force into distance, and force is equal to mass into acceleration. Force is equal to mass into acceleration into distance. So the SI unit of mass is kg, the SI unit of acceleration is meter per second square, the SI unit of distance is meter, and for Kelvin to the power -4 it would be just Kelvin to the power -4 and kg inverse. So after substituting the value, we get the unit as meter square per second square Kelvin to the power -4. So meter square per second square Kelvin to the power -4, that is B. Question number 3. In making reasonable estimates of physical quantities, which statement is not correct? So which statement is false or not correct? The frequency of the sound can be the order of gigahertz. So gigahertz is such a large quantity that giga means 10 to the power 9, so 10 to the power 9 hertz, and normally for audible range the frequency of sound is 20 hertz to 20 kilohertz, that means 20 into 10 to the power 3. So if we compare, then 10 to the power 9 is much higher than 10 to the power 3, therefore it would not be a reasonable estimate of the frequency of sound. Or if we discuss it deeply, then V is equal to F lambda, and lambda would be V by F, and for sound, since it is a sound, so it has a speed of 330 or between 300 to 350, that is 330. So it has a speed of 330 and frequency is gigahertz, that means 10 to the power 9 hertz. So after substituting the value, we get the wavelength as 3.3 into 10 to the power -7, and this wavelength, that is 10 to the power -7, is the wavelength of light, that is 4 into 10 to the power -7 to 7 into 10 to the power -7. So if we compare this wavelength with the wavelength of light, then we can see that this wavelength is same. So if we just think carefully, then the sound has a wavelength that is much greater than light, but here we can see that the wavelength is equal to light, so this statement is wrong. So the option A is the wrong statement, so it is correct. Also, if we see that the second statement, the wavelength of light can be the order of 600 nanometer. So 600 nanometer means 6 into 10 to the power -9, 6 into 10 to the power -7 meter. So here we can see that it is in the range of light, so this statement is correct. Then the Young modulus of a metal can be order of 10 to the power 11 Pascal. Since it is a metal, and as we know that the equation for Young modulus is equal to force by area extension divided by original length. So as we can see that for Young modulus of a metal, since it is a metal, so it requires a large amount of force to extend the metal. So yes, this statement would be correct, and due to this large amount of force, that is large amount of force needed, so the Young modulus must be high. So this statement is also correct. Then beta particles are associated with 1 unit of negative charge. Yes, this statement is correct because beta particles are also negative charge. The only statement that is wrong is statement A, because the frequency of sound cannot be that much higher, that is gigahertz, and if the frequency is gigahertz, then the wavelength becomes equal to the wavelength of light. So this statement is wrong because the wavelength of sound is much higher than the wavelength of light. Question number 4. A calibration graph is shown for emitter whose scale is inaccurate. So the scale is inaccurate, that means the emitter reading is inaccurate and the current is obviously accurate. Two readings are taken on the meter at different times during an experiment are 0.13 milliampere and 0.47 milliampere. By how much did the current really increase between taking these two readings? So 0.13 and 0.47 are the readings on the meter, that means the readings on the emitter. So 0.13 is on the emitter, so if we draw the line and found the corresponding point, then it would be 0.14, and since 0.47 is also on the meter, that is on the emitter, so on the emitter that is 0.47, so in actual it would be 0.42. So 0.42, 0.42 and 0.14, 0.14. So if we calculate, then we need to just find that how much did the current really increase. So how much the current increases. So in reality, between these two values, how much the current increases. So larger value minus smaller value, we would get the increase, that is the increase comes to be 0.28. So the 0.28 is approximately equal to 0.30. So the answer would be A. In question number 5, 4 identical rods have a square cross section. The rods are placed side by side and their total weight is measured by vernier calipers as shown. So this is vernier caliper, 4 square rods with cross section. So this is 1, 2, 3, 4. 4 rods are placed. The measurement is 8.4 plus minus 0.1 millimeter and the zero error on the caliper is 0.0 plus minus 0.1 millimeter. What is the weight of the rod? So to find the weight, that is W, since it is the weight of 4 rods, so for one rod it would be just 8.4, that is 8.4 divided by 4, so the weight of one rod is 2.1, so it could be either A, B, C or D. And what is the uncertainty? We can see that before starting any reading, that means at point 0, when these 2 points are touching, that is this point and this point are touching, then that means at 0 reading we get a value that is 0.1 as the zero error. Then as the measurement is taken, we get an error of 0.1, that is the extra. So in total the error comes to be 0.1 plus 0.1. So this error is for 4 readings. So for one reading it would be just this value, that is the added sum divided by 4. So we get the uncertainty as 0.05. So it would be the 0.05 and 2.10. So the answer should be B. Question number 6. A light meter measures the intensity I of light incident on it. Theory suggests that I varies inversely as the square of distance. That is, I is inversely proportional to distance square. Okay. Which graph of the results supports the theory? So since I is inversely proportional to d square, that is, if we just plot the graph of I against d, then since it is inversely proportional, so the inversely proportional graph would something look like this, that is, it would something look like this. Here is I and here is d, and here we can see that these points do not touch the axis, so this statement is wrong since it touches the axis. This statement is wrong since it touches the axis. Then if we see statement C and D, then here we have plotted the graph of I against 1 by d square. So here we can see that if we see it clearly, then I is directly proportional to 1 by d square. Since it is directly proportional to 1 by d square, so the graph should be a straight line passing through the origin. So the answer should be C. Then for option D, here we can see that I and d square, the graph is something, this is not like this graph, this is this graph, and this graph would something look like the above graph, but this graph is less steep. So the only correct answer is question number 7. One of the equations of uniformly accelerated motion is shown, that is s is equal to ut plus half at square, and here acceleration is uniform acceleration. The apparatus is arranged to record the time taken for the marble to fall between two light gates connected to the timer. The marble touches the stop before it is released. The vertical distance s between the light gate is measured. Fixed stop, this is our marble that falls, and fixed light gate 1 connected to the timer. So this light gate is connected to the timer, and movable light gate 2 connected to the timer. So this light gate can move. So for our diagram, we can see that the ball moves, that is the marble moves, and this light gate moves. Which graph does not show the correct relationship when light gate 2 moves up, that is this light gate 2 moves up to light gate 1, which is fixed. So this light gate moves to light gate 1. Okay, so which graph is wrong, that is not correct. So for our first graph, here we can see that S is S against T. So if we compare with the equation, then this is our S and this is our T square. So we can see that S is directly proportional to T square. Since it is directly proportional to T square, so if it is just directly proportional to T, then it would be a straight line passing through the origin. But since S is directly proportional to T square, so due to this T square, the graph would shift or slightly tilt towards the T axis. That is, S is directly proportional to T square, so the graph would tilt towards the T axis. So this statement is correct, but we need to pick the wrong statement. Then S by T against T. So if we rearrange this our initial equation, then S by T is equal to ut by T, that is u, then half at square by T, that is half at. So if we see this equation, then S by T against T, so as we can see that here S by T is directly proportional to T, so this would be a straight line, but due to the u present, that means it must have some value. Therefore it, instead of starting from the origin, it starts from a larger value. So this statement is also correct. Due to this presence of constant u, that is this value would increase. Then for option C, we can see that u against T graph. So our equation is S is equal to ut plus half a T square. So u against T graph, S is equal to ut plus half a T square. By using the relationship, we can see that if we see here, then this is the value of S, that means this is the value of S. So this is S, and acceleration is constant, half is constant. So T, here we can see that it is the, what is T? So T is the time for marble to fall between the two light gates. So time for the marble to fall between two light gates, that is for this marble to fall between this light gate and this light gate, this is the value of T, that is the time. So this is T, that is the time taken for the marble to fall between these two light gates. So what would be the u? Since S is for this point, time is for this point, that is this area, so u is not the speed at this area, u is the speed at this area when it enters this S. So as it enters this S, we can see that as it is falling, so it must have some value. So the u cannot be a zero value, that is u cannot be a zero value with time. So this statement is wrong. So this could be our option. Again, if I simplify it, then this is our equation. This is the S, and T is the time to fall between these two intervals, that is T. So this is T, this is S, and u refers to the speed at this area. So u is not the speed at this area. At this area speed is obviously 0, but since it is S at this area, so we need to consider the u for this area, not for this area. Since we consider the S for this region, so we need to consider u for this region, that means at the starting. So at the starting, that means at this region, it must have some speed. Since it have some speed, so the graph of T against u cannot be 0, since u must have some value, as it is falling from a height. So u at this point must have some value. So u cannot be a 0 value. So this statement is wrong. So it could be our option. Then here it is a graph of acceleration against time. So if we see it, then acceleration is constant, that is 9.81. So acceleration is constant, that is 9.81. So whatever the value of T, acceleration is constant. So this statement is also correct. So the only graph that is wrong is C. And for this option C, you must remember that u is the speed at this area. since we considered the distance for this area, time for this area, so speed must be for this area, that is, this is the u, and u is falling from a height, so it must have some value, so u cannot be a zero value, so option C is wrong. 8. A stone is dropped from a height 20 meter above the water surface. So this is our water surface, this is the water, and stone is dropped from a height that is 20 meter above. So the graph shows the variation with time for the velocity of the stone. Which statement describes the approximate position of the stone 4 seconds after it is dropped? So after 4 seconds, what is the position of the stone? So as it hits the water surface, it covers a distance that is 20 meter. And from the area under the velocity time graph, we get the distance, and if we see for this area, then if we calculate this area, then it comes to be half base into height, so it comes to be 20 meter. That means at this point it hits the water surface, then after hitting the water surface it must go underwater, so it must go underwater, and after going underwater it covers a distance of, it is the distance between, that is the area under this graph, that is 4 minus 2 is 2 and the height is 5, so the area we get is 10 meter, so it goes to underwater by 10 meter, so it is a distance of 10 meter below the surface of water, so it goes underwater or below the surface of water by 10 meter at 4 seconds, so the option should be B. Question number 9. The water surface in a deep well is 78 meter below the top of the well. So this is the top, that is the top, and here it is water, that is H2O. So a person at the top of the well drops a heavy stone down the well. So a person drops the heavy stone, air resistance is negligible, that means acceleration is 9.81. The speed of sound in air is 330 meter per second. This is the speed of sound. What is the time interval between the person dropping the stone and hearing it hitting the water? So now read this statement carefully. It requires the time interval for the person dropping the stone. That means first of all for the stone drop, that is the displacement of the stone, that is stone, then stone dropping and hearing it hitting the water. So after the stone is dropped, it hears the sound, this is sound. So from this statement, there is time interval between the person dropping the stone, so stone is dropped, that is time interval from the stone dropped and hearing it hitting the water, so he can only hear it by the sound travel, so this is the sound traveling it to his ear. So we need to calculate the time for the stone dropping and for the sound traveling to him. So first of all, time for stone to hit the water, so for the time for the stone to hit the water, S is equal to ut plus half at square. We know the value of S, that is 78 meter, half at square, and initially before the stone is dropped it was at rest, so the total, this statement becomes 0, since u is 0, so this statement is 0. Then S is equal to ut plus half at square, so half acceleration is constant since air resistance is negligible, into t square, so the time comes to be 3.987. Then time for sound to travel, so time for sound to travel to the person, that is S is equal to ut plus half at square. We know the value of S, that is 78, and initially sound must have some speed since the speed of sound is given, so the speed of sound is also constant, so it has a speed of 330 and time plus half at square, and since as I have mentioned that sound travels at a constant speed, as you know that since it travels at a constant speed, so its acceleration must be 0. Obviously the acceleration of sound is 0, so acceleration of sound is 0, so this statement is 0, so the time comes to be 0.236. So the total time for the stone drop and sound travel is this value plus this value, so the answer comes to be 4.22 seconds, so the option D is correct. Question number 10. A golf ball is hit by a club. The graph shows the variation with time of the force exerted on the ball by the club. So this is force against time graph. Which quantity for the time of contact cannot be found from the graph? So for force, we know the two equations of force, that is force is equal to change in momentum by change in time, and force is equal to mass into acceleration. Since we know the value of force and we know the value of time, And here the questions ask for that which quantity for the time of contact cannot be found. So which quantity cannot be found? We know the value of time and we know the value of force. So we know the time and we know the force, so we can calculate the momentum. So we can actually calculate the momentum. Okay, first of all, read the statement. The average force on the ball. So we can actually found the average force on the ball. So this statement is correct. Then change in momentum on the ball. As we know the value of force, we know the value of time, so we can easily calculate the momentum. Then the contact time between the ball and the club. So since we know the value of time, so we can easily calculate the contact time. Then the maximum acceleration of the ball. We know the value of force, but we don't know the mass of the ball. Since we don't know the mass of the ball, so we cannot calculate acceleration. So this statement is correct, that we cannot calculate acceleration. Question number 11. A Gilder of mass 1500 kg is launched from rest on a straight and level track using a catapult. The graph shows the variation with time of the resultant force. Force against time graph. So as we know that force against time graph, the area under the force against time graph is the momentum or change in momentum. If you see it clearly, then force is equal to change in momentum by change in time, and velocity is displacement by time. So area under the velocity time graph would give us displacement. So area under the force time graph, that is force time graph, would give us change in momentum. So what is the change in momentum? The area under the force time graph. So what is the area? Area is, since it is a triangle, so half into base into height. So the height is 10 and it is kilo, so 10 into the power 3, and the base is 40. So the change in momentum comes to be 2 into the power 5. And what is the speed of the Gilder when the resultant force acting on it is 0? That means at this point. So we know the change in momentum, and we know that change in momentum is equal to mass into velocity. So we know the change in momentum value and we know the mass. So what is the velocity at this point? So velocity comes to be 133.33, that is approximately 133. So the answer should be A. Number 12. Which statement about a ball that strikes a tennis racket and rebounds is always correct? So this is the ball, it strikes a tennis racket and rebounds. So which statement is always correct? So whatever the situation is, the total momentum is always conserved and the total energy is always conserved. Kinetic energy cannot be conserved due to the production of heat. So if heat energy is produced, then kinetic energy is not conserved. The momentum of the ball is transferred, or some of the momentum is converted to the momentum of the racket. So the momentum of the ball is not conserved, but the total momentum of the system, that is the ball and the racket, is always conserved. So the answer should be D. Question number 13. In which example it is not possible for the underlying body to be in equilibrium? So the option should be C, that a speedboat changes direction at a constant speed. Since speed is constant but direction changes, as direction changes, so velocity changes, and as velocity changes, so acceleration occurs, and acceleration occurs, and as we know, the resultant force is equal to mass into acceleration, so there must be a resultant force as acceleration occurs. Since resultant force is acting, so the object cannot be in equilibrium. So the answer should be C. In question number 14, two blocks X and Y are falling through a vacuum. Since they are falling through a vacuum, that means air resistance is negligible and the acceleration is constant, that is 9.81. So if we consider two objects, then a larger mass and a smaller mass, and since they are falling through a vacuum, so they have the same acceleration and they would fall to the ground at the same time. So in vacuum, acceleration is constant. So in vacuum, in a uniform gravitational field as shown, block X has a weight 2W, block Y has a weight W. The blocks do not move apart. So the blocks do not move apart. Which value best represents the force exerted by block X on block Y? So what is the force by X on Y? So the force would be 0, because in vacuum they would accelerate at the same rate, that is 9.81. So their acceleration is same, and as their acceleration is same, so the blocks do not move apart. So as it is given that the blocks do not move apart, that means their acceleration is same. But if suppose there is a force exerted on Y by X, that is this force is exerted on Y, then due to this force the acceleration would be greater than 9.81. So the acceleration would be greater, but since they are falling together, or the blocks do not move apart, That means they have the same acceleration, that is 9.81, so no force is acting, so the answer should be A. Question number 15. A gas is contained inside a sealed cylinder as shown. So there is a gas inside the cylinder. The volume of gas at room temperature is 2 cm cube. So at room temperature, that means the initial volume is 2 cm cube. The atmospheric pressure is 101 in kilopascal. What is the work by the gas when heated and expands to a volume of 6 cm cube? So what is the increase in volume? Increase in volume is 6 minus 2, that is 4 cm cube. So what is the work done? We know that work done is equal to force into distance, that is force into distance. Also, there is another equation for work that you need to remember, that work is equal to pressure into volume. So we know the value of pressure, that is 101 kilopascal, that is 10 to the power 3, and change in volume, so the change in volume is 6 minus 2, and since it is in cm cube, so we need to must convert it to meter cube, that is divided by 100 cube. So the work done comes to be 0.404, that is 0.404, and it would be 404. Question number 16. What is the efficiency of CHP station for producing useful power output? So what is the efficiency? We know that the efficiency is the useful power output divided by total power input into 100%. So useful power is this power and this power. So useful power divided by total power, that is total power is this power plus this power plus this power. So in total, the total power comes to be 320. Useful power by total power into 100%. So the efficiency comes to be 81%. In question number 17, in normal driving conditions, an electric car has a range of 150 km. This uses all of the 200 megajoule of energy stored in the battery. With the battery initially fully charged, so the battery is fully charged, the car is driven 100 km. In a normal driving condition, the batteries are then recharged from household electrical supply, delivering a constant current of 13 ampere at a potential difference up to 30 volts. What is the minimum time required to recharge the battery? So it is given that for 150 km, this much energy is used. For 150, 200 energy is used. So for 100, how much energy is used? 200 by 150 into 100. So this much energy is used, and it is in megajoules. So this much energy is used. So we need to refill this energy. That means to recharge, we need to refill this energy. So what is the time to refill? So energy is equal to what? Energy is equal to VIT. Since power is equal to VI, so energy is equal to VIT. So to find the time, we know the energy, we know the value of voltage, and we know the current. So the time comes to be in second, and we need to convert it to hours by dividing with 100, by dividing with 60 to convert it to minute, and then again divide by 60 to convert to hours, and it comes to be 12.4 hours. Question number 18. A fixed amount of gas is reduced in volume. So volume is reduced at a constant temperature. What is the reason for the increase in pressure of the gas? So as volume is reduced, pressure increases. So what is the reason? Because as volume decreases, the frequency of effective collision of the gas molecules with the walls of the container increases, and since the frequency of effective collision increases, therefore the pressure must increase. Again, as the volume decreases, so initially the volume was large, now the volume decreases, so the particles come closer together. So the frequency of effective collision with the walls of the container increases, and since frequency of effective collision increases, so the force exerted on the walls per unit area of the wall increases, and since force per unit area increases, so pressure increases. So the answer should be D. Question number 19. A U-tube closed at one end contains mercury. Air at a pressure of 5 into 10 to the power 4 Pascal is trapped at the closed end. So there is a pressure of 5 into 10 to the power 4 by air. The other end is open to the atmosphere and is fitted to a piston of mass 5 kg and cross-sectional area 5 into 10 to the power negative 4. So for this piston, it has a mass and it has a cross-sectional area. That means it must exert some pressure. The density of mercury is given and the atmospheric pressure is given. So what is the height h of the mercury column? So we need to find this value of h. So for this system, the pressure at this side must be equal to the pressure at this side. Since the system is in at rest or at equilibrium, so pressure at this side must be same as the pressure at this side. So what is the pressure at this area? So obviously since it is open end, so there must be an atmosphere pressure, and the atmosphere pressure is 1.01 into 10^5. So atmosphere pressure plus pressure due to this piston. Since piston has some mass, it has some area, so it must exert some pressure. So the pressure by the piston would be, that pressure is equal to force by area. We know the mass, and force is equal to mass into gravitational field strength. So mass into gravitational field strength, that is 9.81 by area. So its pressure is this value. So at this side there is a pressure of atmosphere, and the pressure due to the piston is equal to the pressure of the trapped air, that is this pressure, plus pressure due to the height of the mercury. So pressure due to the height of mercury. So what is the pressure due to the height of mercury? That is 1.49 into 10^5. So we know the value of pressure, and we know that pressure is equal to rho gh. So the density is given, that is the density of mercury into gravitational field strength into height is equal to the pressure. So after calculating, we get the height as 1.117 meter, and since it is in meter but our answers are in centimeter, so after converting into centimeter, it comes to be 111.7 centimeter, that is approximately equal to 110 centimeter. So the option is D. Number 20. A known tensile force acts on a wire. The wire does not exceed elastic limit. So what is elastic limit? If we consider a force extension graph or a stretch strain graph, then this would be a straight line, and at this point, suppose this is our force extension or stretch strain graph, and this point is the limit of proportionality, and this point is the elastic limit, that is elastic limit. So which two measurements enable strain of the wire to be calculated? So we know that strain is the extension by original length, so we need to know the extension and the original length, that is the unstretched length, that is the original length, and the extension of the wire. So we need both of these two to calculate the strain. In question number 21, the Young modulus of steel is determined using a length of steel wire and is found to have a value of E. So the Young modulus is given. Another experiment is carried out using a wire of same steel but half the length and half the diameter. What is the value obtained for the Young modulus of the second experiment? So what is the Young modulus for the second experiment? So since the same material is used or same steel is used, so Young modulus must be same. So Young modulus must be same, so it must be E. Since the initial Young modulus is E, so the final Young modulus is also E, since the material is same. This is quite similar to density, as we know that since density for a material is same, or whatever the size of the material is, the density is same. This is quite similar to density, that whatever the material is, since the material is same, that means the material is same, so the Young modulus must be same. And the formula for Young modulus is force per unit area extension by original length, that is this formula, that is stress by strain. Question number 22. The graph shows the variation of which states of the strain of a material as it is exceeded elasticity. So this is the limit of proportionality and this is elastic limit. Why is the strain energy per unit volume of the material not the area of the graph? So if we consider it clearly, then instead of being a stress strain graph, it is a strain against stress graph. So this is a wrong graph. It should have been a stress on the y-axis and strain on the x-axis. Then this graph is correct. So the axes are wrong way round. So the option A is correct. Number 23. A wire has a final length of 6 meter after undergoing a strain of 200%. So what is strain? Strain is the extension by original length. What is the original length of the wire? So we need to find the original length, and strain is the extension by original length, and since original length is constant, so we can consider strain as the extension, that is strain as extension. So what is the original length? So first of all, if we consider the original length as x, that is this is the original length as x, then after going an extension of 100%, that is a strain of 100%, That means suppose it is the original length and strain of 100%, so it would be x. Initially it was x, and after the extension of 100% it becomes 2x. So x plus x, that is 2x, and after the extension of 200%, that is another extension. So after the extension of 200%, the length becomes 3x. So 200% is equal to 3x, and we know that 200% is 6 meter, so 3x is equal to 6 meter. So the original length becomes 2 meter. So the original length is 2 meter, that is B. In question number 24, a sound wave is displayed on a screen of the cathode ray oscilloscope as shown. The time base setting is 50 millisecond per division. That means for this one division, the time base is given. So what is the frequency of sound? So to find the frequency, we know that frequency is equal to 1 by time period. So we need to find the time period. And time period is the time taken to complete one complete wave. So here we can see that from this point to this point, one wave is completed. And one wave is completed in 1, 2, 3. So 3 boxes. So what is the time period? So time period is equal to time base, that is this time base, and we need to must convert it to second by multiplying with 10 to the power minus 3, since it is in milli. So 10 to the power minus 3. So time base, and since it covers 3 boxes, so into 3. So this is the total time to complete one wave, and frequency is equal to 1 by time period to complete one wave. So after substituting the value of time, we get a frequency that is 670 Hz. So the answer should be C. Question number 25. Part of a car was damaged by heating when on a sunny day the car was left in front of a curved mirror building which focused reflected sunlight onto the car. So the car is basically damaged by heating. Which statement about the sunlight correctly explains this observation? So why the car is damaged? The car is damaged due to heating of the sunlight, and because infrared radiation is present in sunlight, and we know that infrared radiation causes heating, and due to this infrared radiation the car is damaged. So the answer should be A. And for the other statements, ultraviolet radiation usually causes skin cancer, but the main cause of heating is infrared radiation, so it would not be the answer. Then sunlight is a longitudinal progressive wave. So for sunlight, if we consider infrared or ultraviolet radiation, we know that they are transverse, so this is wrong. Then sunlight is transverse standing wave. This is not standing wave, this is progressive wave. So transverse progressive wave. So the only option correct is A, that is due to this infrared radiation, heating is occurred and the car is damaged. 26. A student sets up the experiment to investigate the double-slit interference of light, but finds that the interference fringes observed on the screen, that means the interference fringes observed on the screen, that is X, is too close to each other to be distinguished. That means the value of X is less. Which change would help the student to distinguish the fringes? That means we need to increase the value of X to distinguish the fringes. So to increase the value of X, we know the equation, that is lambda is equal to X by D. So we need to increase the value of X. So first of all, we need to make X becomes a subjective formula. So we need to increase the value of X. So the option A is correct, and in option A, decrease the distance S between the two slits. So distance S is A, that is this distance, this 2 point is S and this distance is A. So if we decrease the value of A, then the value of X would increase. So the option A is correct. Number 27. Ships have been damaged by water waves with large amplitudes. These waves could have been formed by adding displacement of smaller waves. So which term best describes this phenomenon? So initially smaller waves would interfere constructively and it would form a larger wave. So this is basically superposition, because by principle of superposition we know that the resultant displacement at any point is the sum of the individual displacement of the individual waves. So this is superposition, this is not reflection, this is not diffraction, because light waves does not diffract by passing through a slit, and this is not polarization because no polarized wave is formed. No polarized wave is formed after passing through a polarizing filter, that is this polarizing filter. No polarized wave is formed in which the vibration of the particle is perpendicular to the direction of the wave transfer. So no polarized wave is formed, no diffraction occurs. This is superposition. Number 28. Water waves of wavelength lambda are diffracted as they pass through a gap of width d. So the width, that is d, which combination of wavelength and gap width would produce the greatest angle of diffraction. So it mentions about the greatest angle of diffraction, that means we need to find the greatest value of x. But you must remember that since there is no mention about the diffraction grating, so it is not a diffraction grating question, that is d sine theta is equal to n lambda. Though it mentions about the angle, but it is not the angle of d sine theta n lambda. It is the angle that mentions the value of x. Since it is not a diffraction grating question, this is a diffraction question in which the waves passes through a gap, that is this gap. So which combination would give a largest angle of diffraction, that means the largest value of x. So which combination would give a largest value of x? We know that lambda is equal to ax by d. So after rearranging, x is equal to lambda d by a. So which value would give the largest value of x? So the gap width, that is a, and the lambda. So the value of lambda must be greater, and as we know that x is inversely proportional to gap width, so the gap width must be less. So the gap width is less and the lambda is more, so the option A is correct. So the answer would be A. Number 29 is not in our syllabus right now. Question 30 is not also in the syllabus. In question number 31, the diagram shows a graph for a uniform metal wire. What could the graph not represent? So what would the graph not represent? So for a uniform metal wire, we know that current is directly proportional to potential difference, so it would obviously pass through the origin and it would be a straight line. Then as we know that resistance is equal to resistivity into length by cross-sectional area, so resistance is obviously directly proportional to length. So this statement is also correct, but we need to find that which is not representing this graph. Then resistance, okay, so first of all, potential difference against current. So as we know that potential difference is directly proportional to current, so this is obviously our graph. But resistance against temperature, we know that increasing the temperature increases the resistance, but this is not directly proportional. This would just increase, that means increasing the temperature would increase the resistance, but this is not directly proportional, that means it does not pass through the origin. Resistance is proportional to temperature, but resistance is not directly proportional to temperature since it does not pass through the origin, so the option C is the wrong graph, or it would not represent this graph, so the option C is correct. Number 32, an iron wire of length 8 meter and diameter 0.50 millimeter. The wire has a resistance R. A second iron wire has length of 2 meter and diameter of 1 millimeter. What is the resistance of the second wire? So for the first wire, as we know that resistance is equal to resistivity into length by cross-sectional area, that is resistivity into length, and cross-sectional area we write as pi d square by 4, that is 4 comes at above. So by using this equation and the information that we have given, that the wire is same, that means the resistivity is same, and 4 is also a constant, pi is a constant. So by using this relationship we can see that there is only length that is varied and diameter that is varied. So resistance is directly proportional to length and inversely proportional to diameter square. So we can write this equation as the other things are constant, so we can write this as resistance is equal to length by d square. Since as we can see that other things are constant, that is resistivity, pi and 4 are constant, so we leave this constant and we can write this equation. So after placing the value of length and the diameter, we get our first resistance value, and after placing the value of length and the diameter of the second value of the second wire, we get our second resistance value. And if we compare these two resistance value, then we can see that the first one is 32 and the second one is 2. That means the first one is 16 times bigger. So if the first one's resistance is R, then the second one's resistance would be R by 16. So the option A is correct. As we have given that the first one's resistance is R, that means 32 times. So 32 is equal to R. So what would be 2? 2 is equal to R by 32 into 2, that is R by 16. So the option A is correct. 33. An Atlantic torpedo is a large electric fish capable of generating voltage of 220 volt between its tail and its head. This drives a pulse of current 15 ampere lasting for a time of 2 milliseconds. The fish produces 200 pulse. So initially it talks about a pulse, but now there is 200 pulse per second. what is the average power output of the fish. So to find the power, we know that power is equal to VIT, that is voltage into current into time. So we know the voltage, and current would be, for 1 pulse we have given the current, so for 200 pulse the current value is multiplied by 200, and we must convert time from millisecond to second. So the power comes to 1320 watt, that is approximately 1.3 kilowatt. Number 34, a thermistor and another component are connected to a constant voltage supply. The voltmeter is connected across one of the components. The temperature of the thermistor is then reduced and no other changes occur. So for a thermistor, we know that temperature resistance is inversely proportional to temperature, and as temperature is reduced, so resistance must increases. So the resistance of thermistor increases. In which circuit will the voltmeter reading increase? Since the resistance of thermistor increases, so if we connect the voltmeter across the resistor, that is the thermistor, then the voltmeter reading also increase, since resistance is directly proportional to voltage. In all these options, we can see that in option C, this resistor has a constant resistance, and as voltmeter is connected to the thermistor, so since the resistance value increases, so the voltmeter value increases. So the option C is correct. But for option A, we can see that it is clearly mentioned that a constant voltage supply, that means the other component is a constant voltage supply. That means regardless of thermistor, the other component, that is this component, is a constant voltage supply. But for option A, we can see that this is thermistor and this is light dependent resistor, and light dependent resistor is not a constant voltage supply, so this is wrong, because for light dependent resistor the resistance can vary. Also, as we can see that both are arranged in parallel, so the resistance value is obviously less than compared to option C. Then for option B, as the voltmeter is connected to light dependent resistor regardless of thermistor, so the voltage reading is less. Also for option D, as we can see that the voltmeter is connected to a variable resistor instead of thermistor, so the option D, the voltmeter reading is less, so the option D is wrong. So since decreasing the temperature would increase the resistance of the thermistor, and we need to get a larger voltage reading, so as resistance of thermistor increases, and to get a larger voltage reading, we must connect the voltmeter to the thermistor. So here we can see that the voltmeter is connected to the thermistor, and so we would get a larger voltage reading. So the option C is correct. 35. A 110 volt DC supply is connected to a heater, a fuse and a switch. This is heater, switch and a fuse. Owning a fault in the system, the power is not supplied to the heater. So if there is a fault, then the fuse would melt and there is no power supply to the heater. A technician diagnoses the fault using a voltmeter. He closes the switch and connects his meter between the positive terminal and the fuse F2. The voltmeter reading is 110 volt. Which diagnosis is correct? Since there is a fault that is already diagnosed, so since there is already a fault, so due to this fault the fuse would melt and broke the circuit. So number 36, the diagram shows a potentiometer and a fixed resistor connected across 12 volt battery of negligible internal resistance. So the battery has no resistance. The fixed resistor and the potentiometer each has a resistance of 20 ohm. So 20 ohm and 20 ohm. The circuit is designed to provide a variable output voltage. What is the range of output voltages? So first of all, if the contact is at this point, then as we can see that there is no resistance, so the voltage value is 0. That is given in the first A and B, so C and D are wrong. Then if the contact is at this point, that is the highest point, then we would get a voltage that is V2. So V2 is equal to R2 by R total into V total. So we would get a 6 volt. So the highest voltage is 6 volt. So the option A is correct. Number 37. Radioactive decay is random. What is meant by the term random? So before discussing what is random, first of all, so radioactivity is basically the decay of unstable nucleus to form a stable nucleus by emitting these radiations. So unstable nucleus decays to form a stable nucleus is called radioactivity, and radioactivity can be random and spontaneous. Random means that suppose these are our radioactive nucleus, and you cannot tell specifically that which nucleus would decay. That means random means that each unstable nucleus has equal likely probability of decaying. So each unstable nucleus has equal likely probability of decaying in the nucleus. That means each unstable nucleus has equal likely probability of decaying in the nucleus. That means you cannot tell that which nucleus would decay, because each nucleus has equal probability of decay. So each nucleus has equal probability of decay is called random. That means you cannot tell specifically that which nucleus would decay. So random means that each unstable nucleus has equal likely probability of decaying in the nucleus. And when random decay occurs, there is a fluctuation in reading. That means suppose at a time 2 nucleus decay, then at a time 5 nucleus would decay. So you cannot tell specifically that which nucleus would decay at a time. So at a time different number of nucleus decay, so there is a fluctuation in reading occurs. And spontaneous means that the rate of decay, that means as the decay occurs, it is not affected by external factors such as temperature, pressure, etc. So as the decay occurs, it is not affected by temperature or pressure or any other external factors. So spontaneous means that the rate of decay is not affected by external factors, experienced by no change due to change in external factors such as temperature, pressure, etc. So radioactivity means that a unstable nucleus decays to form a stable nucleus. Random means that which nucleus would decay, you cannot tell specifically that which nucleus would decay, because each unstable nucleus has equal likely probability of decaying, and at a time different numbers of nucleus would decay, so there is a fluctuation in reading occurs. And spontaneous means that the decay that occurs is not affected by temperature or pressure. What is meant by the term random? As we have discussed that random means each unstable nucleus has equal likely probability of decaying in the nucleus. So the nucleus at a constant probability of decay per unit time. So nucleus at a constant probability of decay. This would be the answer. And for the rest of the statement, the decay of the nucleus is unaffected by temperature. This refers to spontaneous. Then the decay of the nucleus is unaffected by pressure. This is the observation for being spontaneous but not random, and we need to describe what is random. Then the decay of nucleus can be predicted. This is unpredictable. So these three statements are wrong, and random means that each unstable nucleus has equal likely probability of decaying in the nucleus. The nuclei of isotopes of an element all contains the same number of certain particles. What is the particle? So as this particle is for an element, so an element contains the same number of protons. So the answer would be D. In question number 39, which statement about the nuclei is correct? So the option would be D, that nuclear number, that is the number of protons plus neutrons, that is the total number of protons plus neutrons, are unchanged by the emission of beta particle. When beta minus particle decay occurs, neutron changes to a proton, beta minus particle, and an antineutrino, and when beta positive particle is emitted, that means positron is emitted, then proton changes to a neutron, positron, and a neutrino. As we can see that neutron changes to a proton or proton changes to a neutron, the total number of nuclear number is the same, so the option D is correct. But for option A, we can see that different isotopic nuclei have different number of protons. No, proton number is the same, neutron number is different. For some nuclei, the nuclear number can be less than the proton number. This is wrong, because nuclear number is basically the sum of the proton plus neutron, and since it is the sum of the proton, so proton number can be, nuclear number is always greater than or equal to the proton number. Then in option C, in some nuclear processes, the mass energy is not conserved. The mass energy is always conserved, the momentum is always conserved, and the total energy is always conserved. So this statement is wrong. Question number 40. What are the values of x, y, and z? So what is x? So here it is x. So by beta emission, we know that beta particle has a mass of 0. Since it has a mass of 0, so the mass number or the nuclear number remains the same, that is 228. So the value of x is 228. Then here we can see that by the emission of Y, mass number remains the same. That means beta particle emission is occur, and as we can see that 89 to 90, that means the proton number increases by 1. That means here it is beta minus emission. As we can see that since by neutron decays to form proton and beta minus particle, since proton number increases by 1, so beta minus emission occurs. So it will be beta particle, not alpha. Then by alpha emission, so alpha has a mass number of 4 and a proton number of 2. By alpha emission, here we can see that the mass number decreases by 4, so the proton number must decrease by 2, that is 88. So what is Z? As we can see that the proton number of Z is 88 and the proton number of Ra is 88, so Z must be Ra. Because neutron number is different due to different isotopes, but proton number is same, that means it is Ra. So the option is B. B is correct.